In class activity 12B, can you hear me now? Ben lives in a rural area along a road that runs east-west. He has no cell phone reception at his house because the nearest cell phone tower is 60 miles away, and the signal from the tower only carries for 45 miles. The cell tower is northeast of Ben's house, and the angle between the line segment connecting Ben's house to the tower and the road is 39 degrees. See diagram below. Let me just scroll down a bit so we can include the diagram. Part 1 says, by driving east on the road, will Ben eventually come within range of the tower? Let me expand the page here. And the answer is, we can put yes, he will come within range of the tower. And we could say something like the perpendicular distance. And we can call that perpendicular, and I'll put this on the graph. I'm going to call it H. From the cell tower to the road is, we can write this as H is equal to 60 times the sine of 39 degrees. And if we work this out, it's about 37.8 miles. So some portion of the road around the point that we can, we'll mark P in the diagram. Let me just draw this for you here. I'm going to draw like a dashed line here. And this is our right triangle. And there's the point P. So that's what I was referring to. It says, so we can say some portion of the road around the point marked P in the diagram shown will be less than 45 miles from the tower. And where this piece comes from is, if we start back one step, we know that the sine of 39 degrees is, you can say opposite over hypotenuse or so forth, or y over r. It's going to be defined to be the opposite, which I call h, over 60. So if we arrange this equation so that it's solved for h, we'd have h equals 60 times the sine of 39 degrees. And that's how we came up with that first piece there. Let's go to the next screen. Objectives for the activity. You will understand that using the law of sines to solve for an angle may lead to no solutions, one solution, or two solutions. You will be able to use the law of sines to determine missing angles in triangles. So, next page. This says questions 2 and 3. You will determine how far Ben must drive from his house before he picks up a signal from the tower, and how far along the road he may drive before losing the signal again. If we let A1 and A2 be the points along the road where Ben first picks up and then loses cell reception, as shown in the following diagram. So we see A1 is here and the A2 is right there. Now, part 2, or question 2, I should say, find the missing angle and side lengths of triangle A1, B, C1. How far does Ben have to drive from his house before he will have cell reception? So what we could do is, and hold on. Okay, so here we go. Sorry about that. So what we want to do is look at the triangle here, and I know that we have, let's see, A, or side A, over the sine of angle A1, and we're going to set that equal to side B over the sine of B. If we go ahead and fill in what we can here, we see that A is 60. So there's the numerator of the fraction. And then the sine of, instead of A1, we can use, let's see, A1, sorry about that. And that's going to be equal to 45 over sine of 39 degrees. So I'm going to scroll down here. Now let's rearrange this. We can write this as the sine A1 is equal to 60 times the sine of 39 degrees over 45. So we could write this as the arc sine of 60 times the sine of 39 degrees over 45. And remember, this is going to be our A1. So if we calculate this, and it's going to move across the screen here, we find that A1 is equal to 57.04 degrees, but this is our reference angle. Okay. So what we need to do is take 180 degrees minus the 57.04 degrees, and we end up with 122.96 degrees, which is pretty close to 123 degrees. So we see that A1 is just about 123 degrees. Okay, so let's put the 123, and it's not writing again. Let's try this, 123 degrees on the graph, on the picture there, the triangle. And let's find out, it's going to be pretty easy to find C1. So let's take 180 degrees minus 39 degrees minus 123 degrees, and we end up with 18 degrees, and that's C1. So I'm going to put 18 degrees up there for C1. So the last part that we have to find now is the side C1. We can use the law of sines to do this. And let me just scroll up so we can see the triangle before we start writing again. So what we could do is write 45 over the sine of 39 degrees is equal to side C1 over the sine of 18 degrees. Now that we have that, let me just scroll back down and continue here. If we rearrange this so that it's solved for C1, we would get C sub 1 is equal to 45 times the sine of 18 degrees, and that's all over the sine of 39 degrees. And this ends up being about 22.1. That's going to be miles. So I'm going to go back up to the graph here, and side C1 is about 22.1 miles. Okay, so this means that, oops, it's not writing again. Let's try again here. This number here, 22.1 miles. It means Ben must drive approximately 22.1 miles from his house in order to pick up a signal from the cell tower. Next page, part 3, it says find the missing angles and side lengths of triangle A2, B, C2. How far can Ben drive and keep his cell coverage? So here we have the triangle, another version of the triangle again. And let's see, the easiest thing I see to do is, let's see, oh, we already found A2, but A2 is equal to 57.04 degrees, or we could just say 57 degrees. And then we could take 180 minus 39 minus 57. And we do this, we get 84 degrees. So that is C2, the angle. So I'm going to put 84 degrees up there. So all the angles are known. And now we can use and apply the law of sines to finish this. Let me scroll down here, make some more room. And let's say we could take B over sine B. That's equal to C sub 2 over sine of 84 degrees. So if we rearrange this, I'm going to solve this for C sub 2, and we get 45 times the sine of 84 degrees all over sine of 39 degrees. All right, when we calculate this, this comes out to about 71.1, and that's miles. So what that tells us is when Ben is 71.1 miles, or approximately 71 miles away from his house, he will maintain the signal. He'll lose the signal. And let's see, how long did he have it? He had it on the previous screen. What was it, 22.1? So he had it for 22.1, then he went down to 71.1. And so if we subtract these numbers, the difference between them is about 49 miles. So Ben will maintain the signal for about 49 miles while he's driving. Let's go to the next screen. Part 4, how would this problem change if the given angle was 57 degrees rather than 39 degrees? And we have a new diagram here as well. Okay, so before we do this, let me go back here. I'm going to go back to screen 1, and it says the signal from the tower only carries for 45 miles. So let's go back here and make a triangle. Here's our right triangle. There's our right angle. And why don't we write the sine of 57 degrees is equal to, I'm going to call this h again. So h over 60, which is the hypotenuse. So if we rearrange this to say h is equal to 60 times the sine of 57 degrees, we get a number pretty close to 50.32, and that's in miles. But remember, the distance, the signal for the tower only reaches 45 degrees. So let me erase the h there. So the signal may only go down to here, which is 45 degrees, 45 miles. And this whole distance is 50.32 miles, just a little more than 50 miles. So the problem with change is Ben would not get reception at all if it was that far away, because the signal does not reach 50.32 miles. All right, that's the end of this video. Thank you.